Hello, everybody. Welcome again to another workshop session from our Block Magic Hackathon. Before starting, I would like to ask you all to leave your like. It's really important for us. And also subscribe at our YouTube channel. Today we have a really special guest. With us is Antonio from ZkSync that will be sharing his knowledge and a lot of interesting things with you guys. So, Antonio, I would like you to introduce yourself. And yes, it's your stage, man.
Okay, yeah. Well, first of all, thank you for having me. Thank you for organizing the hackathon and doing all the work behind the scenes with organizing all the workshops, etc. And yeah, my name is Antonio, and I'm a developer relations engineer at Matter Labs. And Matter Labs is the company behind ZkSync. And yeah, today we're going to be talking about developer experience on ZkSync and how to build smart contract accounts and paymasters using native account abstraction. So I'm gonna make this full screen. And yeah, before we start, I'd like to mention obviously that we are one of the sponsors of the hackathon, and we have $25,000 in these two bounties. The first one is Chainlink integration in ZkSync. So basically, build any application or smart contract that uses Chainlink price feeds and on ZkSync. And the other one is building applications that use native account abstraction on ZkSync. It can be a smart contract account, a paymaster, or anything that uses native account abstraction. And for that, there is the second half of this presentation will explain how we implement native account abstraction on ZkSync and how you can build both smart contract accounts and paymasters. So yeah, stay tuned for that. So this is the agenda for the next 45 minutes or so. First, we're going to see what is ZkSync, just a quick overview in case someone is new to layer 2s or not familiar with ZkSync. Then we'll do a quick recap on how do you actually use and develop applications on ZkSync. We'll continue with an overview of the different tools that we provide. And finally, this is the part that is more important for the bounties is I will talk about how ZkSync implements native account abstraction, the improvements that it has over EIP 4337, and how you can create smart contract accounts and paymasters. So yeah, a little bit more about myself. As I said, my name is Antonio, and I'm a developer relations engineer at Matter Labs. I have around 15 years of experience developing software in a lot of different roles, both in engineering and product. And as a DevRel, my job is to help projects build on ZkSync, but also to educate developers about all the awesome features of ZkSync and the different tools that we provide. Apart from that, Ufano, it's my Twitter handle in case you want to follow me. And ZkSync Devs is also the official account where we provide updates specifically for developers. So yeah, if you want to follow them, there they are. So first of all, what is ZkSync or ZkSync Era? ZkSync Era is a general purpose layer 2 rollup that scales Ethereum with zero knowledge tech, and it's powered by ZK EVM and has native account abstraction. And that's like a mouthful. And there are 4 important bits in that phrase. The first one is that it's a layer 2. That means that it's connected to Ethereum and it scales Ethereum's throughput and reduces transaction fees by bundling transactions together into batches and then sending the output of those transactions to Ethereum. Then it uses zero knowledge proofs, which means that we generate a proof that the transactions in a batch produce a new state, and we verify that proof in the layer 1 in Ethereum before updating the state. It runs on a ZK VM, which is programmable with Solidity and Viper. and the API of the nodes is compatible with the Ethereum API. So from a developer point of view, everything is the same. You write smart contracts with Solidity and Viper, and if you interact with the node, you can run methods like send transaction or get block. Everything is exactly the same. And finally, it has native account abstraction, which means all accounts on ZkSync are smart contract accounts. There are no EOAs, but you can still use MetaMask or the wallets that everyone is familiar with. And we do this because behind the scenes, we are assigning smart contract accounts to externally owned accounts. And we'll get into more details about that later. So that's ZkSync era. But how does it actually work? How these layer 2s work? Well, they work with the smart contracts. So ZkSync has smart contracts deployed both in the layer 1 and in the layer 2, and these contracts interact with each other to keep the consistency of the state. Once the system generates a zero knowledge proof for a batch of transactions, this proof is sent to the layer 1 with the state changes. And then the contract in the layer 1 validates the proof and updates the state. And as you can see in this diagram, the layer 2 generates blocks much faster. Then that's what gives us this increase in throughput. And once it has enough transactions, it seals a batch, generates the proof, and then sends it to Ethereum. So that's how it actually works. But as a user, how do you actually interact with ZkSync? So the first thing that you will do is to deposit funds in the contract in L1. And for this, you will use the official bridge or any of the third-party bridges that we support, like Orbiter or Across, for example. Then what we do is we lock those funds, is ETH or any ERC20 token. We lock them in the contract in R1, and we mint them in the layer 2 in ZkSync. So now your funds are available on ZkSync. Now you can interact with any app deployed on ZkSync. And when you submit a transaction, this transaction is executed by the ZkVM on ZkSync. When there are multiple transactions, just from you or from any other users, they are bundled together into a batch. Then a zero knowledge proof is generated, and then the proof is sent to L1, and the proof is validated, and finally the states and balances in the L1 smart contract are updated. And this process of bundling transaction together, generating a proof, sending it to L1, and updating the state is happening constantly. So how fast it happens, it depends on the activity of the network, but more or less, L2 blocks are generated every 1 or 2 seconds. So transactions are basically instant. You won't be looking at your wallet, waiting for it for the transactions to be processed. There is no need to speed up the transaction and send in more cash or things like that. Every batch that we generate can hold up to 4,500 transactions currently, and this is a setting that we can tweak in the protocol. When we deployed more than a year ago, the limit was like 500 transactions per batch. Then we updated to 700, then 1,000, then 1,500, and now we are at 4,500 transactions per batch. Then batches are closed every 5 minutes or so, and there are different causes for us to close a batch. It can be the number of transactions. It can be the limitation on the circuits that we use, but normally batches are closed every 5 minutes. And finally, the transaction fees are super low, between less than a cent and 3 cents of a dollar. So that's pretty fast and very, very cheap compared to Ethereum. Okay, so that's an overview of what is ZkSync, how does it work at a very high level. Now, how do you start building applications on ZkSync? So first, all the frameworks that you are familiar with support ZkSync. That means you can use Remix if you want to deploy something from your browser. You can use Hardhat or Foundry. And Atlas, I mentioned Atlas here because it's similar to Remix, but it also has an integrated AI, and you can use it to help you generate contracts. It's super cool. So yeah, check it out if you don't know about it. When it comes to writing your smart contracts, you will use Solidity or Viper. And if you already have an application built in other EVM, you are most likely good to go, and you won't need to do any changes in your smart contracts. Next, you need to compile your contracts using our spatial compilers. This is slightly different. Our compilers are called ZkSync and ZkViper for Solidity and Viper, respectively. And we use different compilers because the bytecode that they generate is compatible, is the bytecode that is special for our ZK EVM. Now, if you are building a front end, you can use VM, WAGMI, Wallet Connect, or ZkSync Ethers, which is an extended version of Ethers with ZkSync specific methods. But this is only required if you are using any ZkSync specific features like native account abstraction. If not, again, you can use Ethers out of the box or VM, WAGMI, the typical libraries that you will use. And if you don't have a front end, or you have it, but you also as well need to write other type of scripts, you can use any of our available SDKs. We have SDKs in JavaScript, Go, Python, Rust, Java, and even Swift. So everyone has access to SDKs on ZkSync. And yeah, that's basically it. That's how you build applications on ZkSync. So what about ecosystem tools? So of course we got you covered as well. Chainlink supports has price feeds on ZkSync. We have the graph as well to index data and query it using GraphQL. ThreadWeb is super popular. It has a CLI, and they also provide a lot of project templates which are compatible with ZkSync. Alchemy, one of the most popular node providers, and they also have different APIs, again compatible with ZkSync. And Dune Analytics for dashboards, creating dashboards, again also compatible for ZkSync. And I was trying to put a list together of different ecosystem tools, but there are many more. So any tool that you can think of supports ZkSync. If there is a tool that doesn't support ZkSync yet, just send me a message and we will make it happen. Because yeah, most of the tools will support ZkSync already. So we've seen an overview of ecosystem tools and a pretty high level on how to build, but one of the most important tools to build on ZkSync is ZkSync CLI. And this QR code, I think it sends you directly to our docs, to the page of our docs about ZkSync CLI. And in general, ZkSync CLI is a command line tool that simplifies the process of developing applications of ZkSync. So it allows you to use ZkSync CLI create to create different types of projects, and it provides different templates. So you have Hardhat and Foundry templates. You have front-end applications for ready to go with React, Vue, and Svelte, and even scripting projects using Ethers, Web3.js, or VM. So yeah, you can just run npx ZkSync CLI create, and then in the name of the project, and just follow the instructions, and yeah, we'll create a project for you. You can also run ZkSync CLI dev start to run ZkSync locally. And I'm not just talking about a ZkSync node for testing. It will also spin up, if you want to, a block explorer and a bridge portal. So you can have the same experience that it's happening on testnet and on mainnet locally on your laptop. And yeah, you can install ZkSync CLI using this command, but if not, you can just run every single command with npx and you will get the latest version always. So yeah, that's the best way to start developing in ZkSync is using ZkSync CLI and one of the template projects that we provide. When it comes to Hard Hat, we have a single plugin that enables all ZkSync features. And we used to have different plugins before, but now it's just a single one. It's called MATLAB's Hard Hat ZkSync. And yeah, you just install the plugin, import it in your Hard Hat config file, and that's basically it. When you add the ZkSync network to the list of networks, there is a flag that you need to include, like this ZkSync true. And that basically tells Hard Hat that, hey, this is a ZkSync network, so you need to use the specific ZkSync compiler and the specific ZkSync node when you're running the tests. With this plugin, you also get a lot of helper methods to create proxies, like transparent UUPS and Bitcoin proxies that are compatible with ZkSync. And you also get contract verification tasks out of the box. And obviously, any other community plugins for Hard Hat, like TypeChain, Hard Hat Deploy, Contract Sizer, etc., they just work out of the box with ZkSync. Next is Foundry, which I think is everyone's favorite lately. A lot of people are migrating from using Hard Hat to using Foundry because you can use Solidity across Solidity for everything, not just for smart contracts, but for testing and for scripting, etc. And with Foundry, we started working in a fork of the Foundry code base that integrates both the ZkSync compiler and the ZkSync VM for testing. You can install it by following the instruction in this repo, and also in this QR code will get you there. And the way it works is everything is integrated and it's happening happens behind the scenes. So you can use forge or cast with the --ZkSync flag, and that will tell Foundry to use our compiler and our node. For example, if you run forge build --ZkSync, it will compile the contracts on the project using the ZkSync compiler instead of the Solidity compiler. And if you do forge create --ZkSync, it will deploy the contracts to ZkSync, etc., etc. So yeah, we know that having a fork is not the ideal. So our goal is to take all these changes that we are doing and merge them into the official Foundry repo. And that's something that we hope to get soon. Okay, so that's basically how to do what is ZkSync, an overview of the developer experience. So now I would like to talk to you about account abstraction, which is one of our bounties. So what is native account abstraction? To understand native account abstraction, first we need to understand what is the current state of account abstraction in general in the Ethereum ecosystem. So we have EIP 4337 that brought account abstraction via the entry point contract. And this was released around a year ago and improved things, I would say improved things a lot because it brought smart contract accounts and paymasters, but it's not a complete account abstraction implementation. And so there are other EIPs under discussion. So we have EIP 3074, we have EIP 5003, and more recently Vitalik published EIP 7702, which adds a transaction type that sends a contract code and signatures. And there are even more EIPs about account abstraction. So in the meantime, we're stuck with EIP 4337, and yeah, we're just waiting for other EIPs to be merged and trying to keep up with all these proposals and all these numbers, which is getting a little crazy. So what we have today is EIP 4337, and I will explain how it works. Because it introduces like a few new concepts to the transaction flow. So first we have the concept of user operation, and these are transactions of smart contract accounts. They're not really transactions, but intents of users to do a transaction. Then users send these user operation objects instead of normal transactions to a dedicated mempool. And this is very important to understand how everything works together. In addition to that, we have the concept of bundlers, which are nodes running a specific code. And these bundlers, they are keeping an eye on this dedicated mempool, and they package multiple user operations together and send them to the entry point contract. And then finally, the entry point contract is like an Ethereum system contract that receives these user operations and executes them. So in summary, EIP-457 created a new transaction flow for smart contract accounts. And you can see it here. On the top, we have a typical transaction flow for externally owned accounts. They send transactions to the mempool, and then we have the nodes and validators validating them and putting them into blocks. And then in the bottom, we have new smart contract accounts. They are sending these user operations to this totally different mempool, and then bundlers collecting them, bundling them together, and sending them to the entry point contract. So we have two different transaction flows, one for EOA and one for smart contract accounts. And the bad part about this is that if you want to use a paymaster, you can see that paymasters are down there at the bottom. So if you have an externally owned account, it's impossible for you to use a paymaster. So there is no gasless transactions or paying gas with ERC20 tokens. That's impossible if you are using an EOA with EIP-4337. So yeah, on one side, EIP-437 brought a lot of good things. So we have programmable smart contract accounts, which can improve the onboarding. There are some accounts that they hide the private keys, so the UX is better. And there is this new concept of paymasters that can be used to sponsor transactions, and they are available for smart contract accounts. But on the other hand, these changes were not implemented at the protocol level, so that's why we have a different transaction flow. And paymasters are not available to externally owned accounts, which is quite sad because like 95% of users still use externally owned accounts. And obviously this change, it had no impact on the transaction fees on Ethereum. So how does ZkSync implement account abstraction natively? First of all, at ZkSync, we have built a new protocol from scratch, and account abstraction has been in our radar from day one. So we've built things slightly different. Account abstraction is integrated at the protocol level. So we have a simplified solution for both users and developers. Smart contract accounts and paymasters are first-class citizens on ZkSync. This means that the protocol knows what is a paymaster and what are smart contract accounts. They follow some rules, and all accounts are smart contract accounts, and all accounts obviously support paymasters. There is a single mempool and a single transaction flow. There is only one type of accounts, and all accounts follow the same transaction flow. No matter if they are, or all transactions follow the same transaction flow, no matter if they are initiated by an EOA or a smart contract account. And EOAs work with ZkSync because under the hood, we assign them a smart contract account, like a default smart contract account. So for a user, you can still use your MetaMask or your Rabi wallet or your Sirion, whatever, EOA. You can send a transaction, and when we pick it up, we say, hey, this is an EOA. Let's use this default smart contract account. So for a user, it's completely transparent, but behind the scene is using a smart contract account. And finally, we have our own version of the bundler and the entry point contract. Our bundler, so yeah, it's similar to EIP-4337. and we process transactions we bundle transactions together, and we process them for all types of accounts. And this is how it looks like. So again, we have externally owned accounts or smart contract accounts sending transactions to the same unified mempool. And then we have our own version of the bundler, which we call the operator. And then this operator sends batches of transactions to our version of the entry point contract that we call the bootloader. And then the bootloader processes the transactions. If there is a paymaster that has to be involved to sponsor the gas fees, interacts with it, and that's it. So you can, if you have, you can send transactions from your MetaMask with a paymaster. It will work. So yeah, we're taking EIP 4337 to the next level. I'm a big fan of penguins, by the way. So finally, how you, as a developer, how can you build smart contract accounts and paymasters on ZkSync, and how can you integrate them in your apps? So first of all, for smart contract accounts, all smart contract accounts have to implement the iAccount interface, which has two required methods. The first one is validate transaction, and obviously this validate transaction, what it does is incrementing the nonce of the account. It checks that the account has enough balance to pay the transaction fees or pay for if it's transferring ETH, whatever. It verifies the signature, and obviously you can do any other validations that you want to add in here. And the execute transaction takes care of forwarding the transaction to the destination contract, passing any value or transaction parameters. So that's basically it. And if the code in here is small, don't worry, because I'll have a QR code with a repo with an example later on. Then this interface has three additional methods, which are optional. The first one is pay for transaction, which basically pays the transaction fee to the bootloader. We have prepare for paymaster, which process any paymaster parameters, and execute transaction from outside, which can be used to execute transactions by other entities instead of the bootloader. And that's basically your smart contract accounts. Obviously, you can implement or extend these methods to do anything that you want, because these are smart contracts, and yeah, you can build any logic that you want. For example, in the validate transaction, you can natively verify multiple signatures, so you can have a native multi-sig account that instead of receiving just one signature, it receives 2, 3, 4, whatever, and you just make verify those signatures in the validate transaction. You can also have different signature schemes. So instead of using ECDSA, if you are using another type of signature, you will have that signature verification here. You can also add validations to have like spending limits, like okay, if this transaction that is being sent is spending more than 1 ETH or more than 1,000 USD, I will not accept it, things like that. And then you can also allow the account to only interact with a whitelisted set of contracts. So yeah, anything you can think of, you can do it. The important thing is that if you are building a smart contract account to ZkSync, you have to implement this iAccount interface and at least implement the validate transaction and execute transaction methods. And actually, the spending limit example that I just said, there is a repo at the end with a tutorial about it. So yeah, if you want to see that example, is a few slides. Next. Okay, for building paymasters, again, paymasters as well, they are smart contracts, and basically the job of a paymaster is to receive a transaction from a user and decide if it will pay the transaction fees on its behalf. So paymasters yeah, again, are smart contracts, and they can implement any logic. But similar to accounts, for Paymaster, we have their specific interface, which is iPaymaster. And Paymasters only have two methods by default. The first one is validate and pay for Paymaster transaction, which basically validates the transactions and pays the transaction to the bootloader, as it says. And the second one is post-transaction, which is optional. And some examples of validations that you can do here is, for example, check if the account that is sending the transaction owns a specific NFT. And if it does, the transaction will be free. And this is something that we are seeing a lot on the ZkSync ecosystem. We have a lot of NFT collections that are partnered up with other applications on the ecosystem. And yeah, these applications, they are saying, okay, if the user owns one of these NFTs, all the transactions will be free. And this happens completely transparently for the users. They just implement it in the app with a paymaster, and yeah, users are just getting gasless transactions. And there are two paymaster flows when you are building paymasters. One is approval based, and the other is general. And I will explain how you actually choose which one to use in the next slide. But basically, the approval base is built for ERC20 tokens when you want to allow users to pay fees with any ERC20 token. And what it does is, you know that when you want to spend ERC20s, you have to first approve and then you have to spend. So instead of that will be like not a great UX for a user if he has to just send a transaction and then make sure that he has to approve the spending. So what we do is we run the approve behind the scenes, so it's totally transparent for the users. For that, you need to specify that you want to use the approval-based flow, and the other one is general, which is used in any other cases. So you build a paymaster, then you want to integrate it into an app. What do you need to do? Well, the first thing that you need to do is deploy your paymaster to the testnet or to mainnet, and then you have to fund it with some ETH, because at the end of the day, the paymaster is the one that is paying the transactions on behalf of the user. It's not that everything is just gasless or yeah, and no one is paying. It's the paymaster is actually paying the transaction fees. So the paymaster has to have some ETH. Then from an application point of view, we need to send the transaction through a paymaster. We need to include additional parameters in the transactions, and these are the paymaster address and the type of flow and any other payload. And for that, we need to include or encode this paymaster with ZkSync Web3 or ZkSync Ethers. ZkSync Web3 is the old version of our library, but you can use ZkSync Ethers, or you can use VM. We have the method get paymaster params, which basically encodes everything, and then you pass it as transaction overrides. And that's basically it. That's how you take to any transaction. You just attach these parameters at the end, and the transaction will be processed by the paymaster. So that's basically it. A few takeaways. ZkSync Era is a layer 2 rollup and is EVM compatible. So all your tools that you're familiar with, like Remix, Hardhat, Foundry, everything works out of the box, and most of the ecosystem tools are available for users. And then we have native account abstraction that is implemented at the protocol level. And yeah, smart contract accounts and paymasters, they are great. Thanks to native account abstraction, we have paymasters for any type of accounts, and building both the smart contract accounts and paymasters is very, very easy. You just have to implement a few methods from two interfaces that we provide. So next steps in this QR code, you have a bunch of links, which probably are the same ones as here. So you can visit our talks to get more information. And in this QR code, I link specifically to 2 tutorials. One to build a smart contract account that has a spending limit, which is super cool. And the other one is how to build an application that basically provides gasless transactions for users that have an NFT, which is the example that I was mentioning before. Then you can join our Discord to ask questions, join the community, follow ZkSync Devs on Twitter to stay updated to all the latest updates for developers. And then obviously ZkSync CLI, which is the easiest way to get started building a ZkSync. And then that's our forum where we have a GitHub discussions forum. So you can just go there if you have any other questions for developers, or if you want to help other developers, you can find them there. And yeah, before I leave, again, I have $25,000 in bounties. The first one is any applications that use Chainlink private on ZkSync, and the other one, build applications, smart contract accounts, or paymasters that leverage native account abstraction on ZkSync. And I think that's all. Yeah, that's it. That was pretty fast, faster than expected. So, yeah.
It was amazing, man. It was amazing. What a class. Thank you so much, Antonio. It was really clarifying, and I believe that many of the participants will use it to empower their projects in the hackathon. So it was really helpful. Guys, just don't forget to register on our hackathon. Let me just share the link with you guys again. Here it is.
I'm gonna leave the QR code there in case there's someone late.
Yes, I also shared this Linktree link. It's in the chat.
Oh,
So,
okay, great.
yeah. So the guys will be able to. If someone missed the QR code, the link is in the chat.
Yeah,
Jeter,
and also,
sorry.
there's a link to the whole presentation in this QR code. So if everyone wants to, they just join halfway. Yeah, they can just go check the slides on their own.
Sure. Let me. I think that I do have the presentation link as well. Let me put this available for everybody. Here it is, guys. The presentation
It
link.
was a long link.
Yeah, a big one. So
I,
again,
I think
Antonio.
I think there is a question. There was a question at the beginning. I don't know if from Arpit Singh. What is the difference between ZkSync and a ZK circuit?
Yes.
So circuits are a part of the protocol, and ZK circuit, I mean, it's like more general. Other ZK rollups, they use circuits as well. So ZkSync obviously is the whole layer 2 with the smart contracts, with the circuits, with the contracts in R1 and R2, with the node. So it's the whole thing. And a ZK circuit is just a part of the protocol that helps helps on the proof generation of generating a validity proof of the new state that is generated after executing the transactions on the layer 2s. So ZkSync is the whole thing. Circuits are just one part of the protocol.
Impossible to be more clear. There is any other questions, guys? Here is the moment. Jeter Rodrigues, one of our advocates from Brazil, he just left a message.
Oh, yeah. Thanks.
Yes,
Yeah.
that's it, man. That's why we organize sessions like this. Okay,
Thank you very
guys.
much for the compliment.
If there is any other question for now, I would like also to share with you guys the workshops calendar link. Here it is. On this link, you can find all the workshops that we do have scheduled for you. And you can just add it to your own calendar and making sure that you won't miss it. What else? Leave your like. Do not.
You guys have data feeds on ZkSync tomorrow as well.
Yes.
So, okay, so, we have 2 bounties for ZkSync, one for account abstraction, which is what I talked about today. And then the other one is data feeds on ZkSync, which is the workshop that you will do tomorrow. So, yeah, that's pretty cool.
That's it. Join us tomorrow again with ZkSync and others protocols. Leave your like, subscribe on our channel, and that's it. Antonio, I have no words to say thank you to you. It was really helpful. We really appreciate when you guys spend some time with our community providing education and teaching us how to explore your tool. So thank you again. And it's your house. It was a pleasure. And anytime you want, we'll be more than welcome here.
Yeah. So yeah, thank you for having me. And yeah, again, thank you for organizing the hackathon and for all the work that you guys do. And yeah, happy to come back anytime.
So here we are finishing our session now. See you next time, guys, and have a beautiful day or beautiful night. Bye-bye.
Bye-bye.